My name's Joshua Chaitin-Pollak. I was an early software engineer at Kiva Systems, which was acquired by Amazon and is now Amazon Robotics. I was the first software engineer at 6 Systems, which was acquired by Shopify. Then I was the head of software at Pickle Robot, and now I am the VP of software at ATI.
Can you tell us a bit about the fleet that you scaled at 6 River? Can you share any stats about how many robots you guys had or how many customers?
Yeah, so we had, let's say, a fleet size from obviously from 0 to around, let's say, low hundreds, 300, 400 robots by the time I left. After I left, it scaled to um, thousands of robots. And while I was there, we had about 15 or so sites across probably 10 or so customers. So a couple customers had multiple sites. We had quite a few sites, and the sites would range from, let's say, 8 robots to 50 robots at a site. Logistics automation and basically e-commerce picking and shipping is obviously a huge growing market. And there's a lot of larger automation systems that really can optimize and move very quickly to ship packages. But a lot of long tail of shipping and e-commerce does not need quite that much volume, and there's a lot of brownfield environments that are still being picked with manual push carts, the lists of sheets of paper. And so 6 River Systems built a robot that would guide an operator to where they needed to be to pick an item and walk them through the entire picking process, so they didn't have to push the cart and they didn't have to have a pick sheet or a manual process for that. So it just optimized their walking and optimized the picking process without having to require a full rebuild of their system.
What becomes true about operating robots at a fleet of 50 or 100 that isn't obvious earlier?
At the smaller scale, every robot is probably a one-off, and they're almost development devices where hardware engineering and software engineering is working on each robot, and they're all individually configured and managed. You probably have development environments on each robot, and each robot might have slightly different variations in mechanical structure. At the fleet scale, when you start to go from 10 to 100, you are deploying to customer sites, you're deploying fleets of robots, and you'll have a single, hopefully, ideally, initially, a cohesive set of robots that are all identically or the same. However, what you'll start to discover is that there are manufacturing issues or tolerance issues or electrical problems that need to be reworked. And so over time, your fleet is going to start varying, and then you'll have a second generation or a point revision of the hardware. And now you need to start managing, well, this set of robots is configured one way, and this other set has some slight variation, and so it needs to be aware of the software, and the software needs to be aware of those variations. And on top of that, how independent each robot is from all the others affects the complexity of your configurations. For example, if you're deploying in robots that take centralized control and they work together as a fleet as a unit, then the server software needs to be aware of all of its robots that it's working with, and if they have any variations in capability or configuration. Whereas if each robot is fully independent from all the others, there's no centralized server that it needs to deal with or take instructions from, then they can be independently managed, and that makes that deployment process much easier.
What are the most important signals that things are about to break at the next scale up of the fleet?
When you start to hand off your robot management to your technical operations team or even to end users, you'll suddenly get all sorts of feedback about usability. People tend to get used to working around issues that they discover with the usability of your robots. And as people become more familiar with them, they won't report issues that they run into. If you listen every time you scale out to a new employee or a new technical operations member, you'll get a lot of feedback about difficulty that they're having using the robot, and that feeds back into, oh, I need to figure out how to improve our workflows or our usability. In terms of scalability, it's a good time to look for failures in the robot initialization process, the bring up process. Are there calibration issues? Do you have tooling or do you have affordances on the robot to actually help with calibrating each individual robot? Do you need to make new configuration changes or code changes to support different models? Handling variations between different models becomes harder. And so you need to start thinking about how you're going to configure and handle those configuration variations between generations and also between instances of it within a generation.
Speaking of usability, you mentioned that you want to get feedback from end users and technical operators. How did you collect that feedback? How did you triage through that feedback to make sure your team was shipping quickly while still attending to the needs of these end users?
Yeah, so here at ATI, what we do is we actually have a Slack channel called Software Feedback. And anytime our technical operations team has a weird thing that happens, they'll put a note into the software feedback channel And that becomes a ticket in Slack. And then I will actually go through and manage that triage and decide whether we already have a ticket in our issue management and our backlog, or whether it's already addressed and it just needs to be feedback, and we handle it that way. We also actually have a separate channel for hardware feedback, and we have a third channel for field support. And all three of those are sort of Slack ticketing systems, and we address them on different priority rates. And I'm not sure that's exactly the ideal solution, but at the scale that we're at, where, we have, 10 or so technical operations people and 20 or so engineers, that seems to be working fine. At a larger scale, you'd start looking into scaling out to on-call support staff and rotation stuff. And we're at the scale that we're at right now, we're right at this edge where it's starting to be a little bit of a pain point, and we need to start making that transition. So I'd say that at that boundary of 10 robots is when you start thinking about, now we need to get on-call rotations. We need to have a more formalized stop process. We need to have a triage process.
Can you talk about some of the operational processes teams should implement as they go from 10 robots past that mark towards 100?
Yeah. So below 10, you might be using development images on your robots. You might be hand editing configuration files on the robots directly. You might be standing at the robot right there. Those things will change as you start to deploy the fleet, and you'll need to start handing off control over the robots to other people, to technical operations or the end users. And so at that transition point, you want to start thinking about, how do we deploy build images, whether it's a Docker container or a disk image or a compiled binary? How do we centrally manage a configuration? Is that stored in a database? Do we have some other way of doing that? And also, you want to have a remote access strategy, especially if you're going to enterprise deployments. You're going to need to have a VPN strategy that you can get past the enterprise IT department of your customers. And so those three things really become important, because you're going to need to start training your technical operations team on how to handle and manage the configuration, how to roll out the deployment software versions and do the upgrades, and how to get into the robots and collect logging and details. And that's a fourth thing, actually, is you need a way to offload your logs from the robots into the cloud and have access for debugging purposes. All of those things, ideally, you're addressing from very early in the process, even before you get to 10 robots, but definitely by 10 robots, you need to start thinking about those strategies.
Startups are notorious for being flippant toward process. What's the fastest way that process becomes fake or ignored, and how do you prevent that for a scaling fleet?
I think you want to keep things as ad hoc and high value as possible for as long as possible. So it's important to have triage meetings, but if there's nothing to triage, don't have the meeting. So you can often you can leave time or leave a moment at the beginning of a meeting or just before the meeting starts to check and see whether it's necessary to meet at all. In addition, automate as much as possible, right? So don't have software engineers manually making releases for longer than they need to. You should automate that release process. You should automate collection of feedback so that technical operations doesn't have to come find somebody and tell them. You can just have a record of that. Safety issues, all sorts of issues like that, hardware feedback, all that should be automated. This should be an automated place to collect all that information, and then a process through which you can triage all that stuff. Likewise, you don't want to get caught up in chasing the most recent issue just because it's like the most recent issue. You need to make sure, is this really impactful? Is this really going to move the needle on our deployments and our scalability? Is it a minor annoyance? One of the things that you discover every time you go through this 0 to 10 to 10 to 100 transition, is that at some point you focus on improving the system capabilities so much that you put aside a lot of bugs and issues and usability issues. And then you start to suffer with the velocity, because your technical operations team it becomes a minefield to work through operating your robot, because of all the different things that they've learned that they have to work around. So you have to figure out what that balance is of pulling in some of the backlog of bugs just to keep the system moving smoothly and deploying smoothly while you keep working on velocity. So that's always like a little bit of a juggling act, trying to keep multiple plates in the air. Is your analytics working? Is your logging working? Is the operation of the robot working? Is the deployment strategy working? Plus you're adding new features, and you probably have a small team, and you have to, sort of keep all those plates spinning at the same time.
Can you describe a bit more, what is the TechOps function and what is their scope of work?
Yeah. So TechOps is basically the go-to-market hands of the robot team. So they're going out into the field, they're deploying the robots, they're maintaining the robots. They're also back in the back headquarters, they're responsible for maintaining and configuring the robots, deploying new versions of the software, preparing and staging releases, especially in an enterprise environment. There's usually a long process of making sure that the next software release has been qualified and tested specifically for that customer's configuration. And for example, at 6 River, we actually had a test environment where we would actually set up a mini version for every customer, deploy their current version of software, actually do a dry run of the upgrade of the software, and validate that the robots and the server software were all working together correctly, and then deploy that to the customer site after it's gone through a series of approvals and checks.
What backgrounds make strong TechOps hires, and what gaps need closing as you ramp up new hires on the job?
Yeah, TechOps are usually mechanical, electrical, software engineers, or other technically minded, recent college graduates. They'll spend a year or two, or maybe a little bit longer, in the technical operations organization, and then oftentimes they'll transition to direct engineering. They can often transition to product management or account management roles. They have to be very personable and customer facing as well as technically minded. So, for example, when we're interviewing technical operations team members, we'll usually have them do a practical assessment on a physical robot, ask them to change a circuit board or make some other mechanical change, and we'll also evaluate their ability to SSH into a robot and make configuration changes, for example. And then they'll also be judged on their ability to interface with customers. TechOps team members usually rotate through a bunch of different organizations, at least meet with them to get a little bit of hands-on experience. They'll meet with the software engineering team, the hardware engineering team. Sometimes they'll meet with manufacturing. They can even spend a few weeks in manufacturing building robots or getting hands-on experience with what it takes to put them together so that they know how to maintain them. Then they'll usually go out on site and act as a junior team member with existing TechOps members, doing some operations there, doing some initial configurations, and just gradually build up to working solo.
What's the right relationship between software engineering, deployment engineering, and TechOps, and what can break when they're misaligned?
I think the most important thing is that software engineering have a responsive relationship with the TechOps or RobotOps team. Oftentimes, RobotOps will have a lot of feedback. They're in the field. They're frustrated. They're trying to get stuff done. Software engineering has priorities from product management for the next customer to ship new features, and build the capabilities of the system. And those are a tug of war. And so you need to be very sympathetic, address TechOps operations issues as much as possible, but also work within the organization to make sure that their issues are being prioritized alongside the product management issues at the same time. And deployment management and deployment engineering needs to be really tight on their release process as best as possible. Make sure that, the software has been validated for as much as possible. Tests are passing, because you don't want to ship broken releases to TechOps. The most stressful environments happen when you ship a release to TechOps. They try and deploy it. It's 3 a.m. Everything's broken. You have to get a phone call from the software team to address some problem. You have to wake up other people, and the whole system just falls apart. And so making sure, that only takes that happening once or twice before you realize you need to really harden your processes. So that happens in that transition from, maybe the 50 to 100 range of things start to happen, and you need to just be on top of that.
What's the biggest bottleneck preventing software teams at robotics companies from scaling their fleets today? And as the software lead at ATI, is there anything that you're doing on day zero to help break through those bottlenecks?
I think the most important thing for robotics teams is to not develop not invented here syndrome, which is to say that if you need to solve a problem, you have to solve it yourself. I think that one of the most important things is to not do anything that is not your core competency. So, for example, leveraging Docker, leveraging configuration management, leveraging outside logging, anything you can pull in to delegate responsibility so that you can focus on your core mission is key.